Okay, we are making our way into the very last act of Unit 2. This is Act 13, and today I just want to go through this word problem with you on solving systems of linear and nonlinear equations. So we kind of have to build our own system, and then we're going to graph it and solve it. Okay? So the nice thing is they give us the quadratic equation that's given in the information in the first paragraph. So we're talking about, two friends that are going up an escalator, and they had each other's keys. So they wrote this function to determine x seconds after throwing them as to when they were going to catch them. So this says when the keys are thrown, Lori's hands are 9 feet above ground and moving upward at a rate of 0.75 feet per second. So write a function f of g, g of x, that gives the height of Lori's hands compared to the ground level x seconds after the keys are thrown. Okay, so basically I'm just going to say g of x equals, I'm going to let the 0.75 feet per second kind of serve as my slope. I'm kind of putting this into mx plus b. So that would be 0.75x plus my y-intercept would actually be where they already are above ground, which is at 9. Okay, so that is my linear function equation. Okay, now they want us to write the system. So the system, I'm going to I'm going to take these both down to y's. So this is my quadratic. And then this is the linear that we just wrote. So this one is my quadratic. Okay, so that's kind of the specialness of this section, is they combine the linears with the quadratics from the first and the second unit. Okay, now we're going to graph this. Now I'm going to attempt to put my calculator under here so you guys can see what I'm doing. I don't have the fancy calculator that Mrs. Thomas uses. So I'm going to plop it in here, and I am going to put in my two equations. So in y1, I'll just put the quadratic one. And then in y2, I'm going to put the linear one. It doesn't matter which one you put it in. You could flip-flop them if you wanted to. Let's take a look-see, and now I'm going to hit graph. Now I've got the standard window right now. So it looks like I need to see a little bit more of the top of my graph, so I'm going to go to my window, and I'm going to change my y max to maybe 30. Let's give it a shot and take a look at it. Oh, that's plenty. Okay, now if you want to generate some points to help us plot it, I'm going to go second graph, and that takes me to my table. Let's see. Probably want some of the smaller ones. So we're going to kind of have to approximate. So I think when I set up my axes, I really only need the first quadrant. I don't know why I have this extra line to back in the negatives on the x scale. So I put 10 tick marks there. I'm going to do maybe 4, 6, 8, 10, 12, 14. Okay, so the linear one goes to, let's see, well, I know my y-intercept is at 9. So I think on this y scale, I want to go by 50s, but let me take a peek here. Oh no, I just want to go by 2s. So maybe 4, 8, 12, 2, 4, 6, 8, 10, 12, 14, 16, 20, 24. And then on my x scale, we're just going to go by 0.2. So that's 0.4, 0.8, 1.2, 1.6, and 2.0. Okay, so if I plot my so if I look right here, I've got 0, 9. It's my y-intercept, so that's going to be right in here. And then let's pick another point we can put out there. 2, 10.5. So that would be like here. And then it's actually kind of hard to do this one. If you have a straight edge, it'd be helpful. Okay. Now I'm going to do my quadratic. So that's my y1. So 0, 5. That's going to be my y-intercept. It's about here. And let's see if I can get where it comes down. It's just getting bigger. I gotta remember I'm on the decimals there, so I gotta, it's a little trickier. 114. Zero, 5. So maybe if I go to my graph, it might be a little bit easier. So if I hit second trace and I do maximum, and then I kind of snuggle my cursor up to on the left side, hit enter, go around to the right side, hit enter, and enter a guess. So that's at about so at about 0.8, we'll say, and then 14.5. So it's about right here. And then I want to figure out this point where it comes down. So if I hit second trace, and I want a 0. So come down here, go left bound, which is right here, right bound, and then enter a guess. And that gives me roughly where it comes down, which is at about 2-ish, so I'm like over here. So it kind of comes up, and then it comes back down like that. Okay? So at least we have somewhat of a picture. Now the whole point of doing this is actually to figure out where these intersect. So I have to go second, trace, intersect. And you guys have done this before. So you just get your cursor kind of close to where they intersect. Where the heck? Oh, there it is. And then you hit enter 3 times. So 1.3 would be one of my solutions. So I'm just going to put this down here. So that was this guy over here. Okay, now I'm going to do it again. Second, trace, intersect. And I'm going to come over to this left intersection point and hit enter 3 times. And that X is about 0.2 if I round it up. So now we have to interpret that. So basically that means you have, you guys can't see that. Just ignore these problems at the bottom. We have 2 chances of catching the keys at about 0.2 seconds after thrown, or about 1.3 seconds after thrown. Just the x coordinates. Of the intersection. Okay, hope you watch this video because it's going to help you on the exit ticket. Good night.